Hello, good day viewers. Here is another logical exponential equation, which is 7 plus 4 root 3 raised to the power of x squared minus 5x plus 5 plus 7 minus 4 root 3 raised to the power of x squared minus 5x plus 5, the whole of this equal to 14. And we are only looking for the real values of x that can satisfy the equation. All right, let's get started. It is so similar to what we have solved yesterday, so let us declare this with y. So let y be equal to 7 plus 4 root 3. And you should know that 1 divided by y will be equal to 7 minus 4 root 3. If I say 1 divided by y, I mean 1 divided by this, right? So 1 divided by y is equal to 1 divided by 7 plus 4 root 3. So we have to multiply the top and the bottom by the conjugate of the bottom in order to rationalize the bottom. So the conjugate is 7 minus 4 root 3. Also the bottom 7 minus 4 root 3. So if you multiply the top, 1 times this is still 7 minus 4 root 3. 7 minus 4 root 3. The bottom is just difference of two squares, right? Just observe, we have difference of sign, plus and minus. So we take the first term, we square that, we subtract, we take the second term, we also square that. You can see the top we have 7 minus 4 root 3. The bottom will be 7 squared is 49. 4 squared is 16. Square root of 3 squared is 3. And 16 times 3 is equal to 48. And 49 minus 48 is equal to 1. So we have 7 minus 4 root 3 divided by 1, which is still 7 minus 4 root 3. You see that? They are just the conjugate of each other. So now let us back substitute. This is y, this is 1 divided by y. So we have y raised to the power of x squared minus 5x plus 5 and plus 1 divided by y raised to the power of x squared minus 5x plus 5, and this is equal to 14, right? We have y to the power of x squared minus 5x plus 5, then plus 1 divided by y to the power of x squared minus 5x plus 5, because 1 to the power of this is still 1, right? So we are distributing the exponent upon numerator and denominator, and this is equal to 14. Another substitution, I would like to declare the whole of this with u. So let u be equal to y raised to the power of x squared minus 5x plus 5. So this becomes u, and this becomes 1 divided by u, right? So we have u plus 1 divided by u, and this is equal to 14. Multiply every single term by u in order to clear this fraction. U times u is u squared, plus u multiplied by 1 divided by u will give us 1, and this is equal to 14 times u, which is 14u. Let us take 14u to the left. We have u squared minus 14u, then plus 1, the whole of this equal to 0, which is now a quadratic equation. The leading coefficient here is 1, so a is 1. Coefficient of the middle term is negative 14, and the constant is 1. So the value of u is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Let us substitute. U is equal to minus b, but b is negative 14. If you minus it, it becomes plus 14, right? Plus and minus square root of negative 14 squared, that is b squared, minus 4 multiplied by a is 1, c is also 1, divide by 2 multiplied by 1, which is 2a. Let's simplify this. 14 plus or minus into square root of negative 14 squared is 194. 194 minus 4 times 1 times 1 is still 4. Divide by 2 times 1 is 2. Let's further break it down. We have 14 plus or minus into square root of 192. Divide by 2. Let us further break it down. This is equal to 14 plus or minus into square root of 192 can be expressed as 64 multiplied by 3. Divide by 2. So this is equal to 14 plus or minus square root of 64 is 8. So we bring 8 outside. Inside we still have 3. Divide by 2. So 14 divided by 2 is 7. Plus or minus 8 divided by 2 is 4. Then root 3. So this is the value of u, which we can split into u1 and u2. u1 equal to 7 plus 4 root 3. Then u2 equals 7 minus 4 root 3. Let us back substitute. What is the value of u? Remember, we have declared u to be equal to y raised to the power of x squared minus 5x plus 5. So u is equal to y raised to the power of x squared minus 5x plus 5. So the first u is 7 plus 4 root 3. But can you remember the value of y? Because we have to plug it back. Y is nothing but 7 plus 4 root 3. So this is 7 plus 4 root 3 raised to the power of x squared minus 5x plus 5. But naturally, this can be raised upon 1. So since the bases are the same, we can equate the exponents, which implies x squared minus 5x plus 5 is equal to 1. And we can take 1 to the left, which is going to transform it to negative x squared minus 5x. As 1 crosses over negative 1, 5 minus 1 is 4. This is equal to 0. Now we're going to think of two numbers which when we multiply them together, we get positive 4. But the moment we add them together, we get negative 5. And the numbers are negative 1 and negative 4. So x minus 1, x minus 4. And this is equal to 0. By setting each factor to be 0, x either equal to 1 or x equal to positive 4. So this is two of our solutions. Then u2 is 7 minus 4 root 3, right? 7 minus 4 root 3 is equal to y raised to the power of x squared minus 5x plus 5, right? But we know that y is 7 plus 4 root 3, then raised to the power of x squared minus 5x plus 5. And remember that this is a reciprocal of this, right? Take reciprocal of both sides. We have 1 divided by 7 minus 4 root 3. This is equal to 1 divided by 7 plus 4 root 3, but raised to the power of x squared minus 5x plus 5. So that we know that this is a reciprocal of this. So instead of this, we replace it with this. 7 plus 4 root 3 is now equal to remove this fraction, we can negate the exponent, right? So it becomes 7 plus 4 root 3 raised to the power of negative version of this x squared minus 5x plus 5. And now you can see the bases are the same. We can equate the exponents. It implies negative x squared minus 5x plus 5 is equal to 1. Multiply both sides by negative, so we have x squared minus 5x plus 5 is equal to negative 1. Take negative 1 inside, it becomes positive 1, x squared minus 5x. That positive 1 plus 5 is equal to 6, and this is equal to 0. Now we think of two numbers which when we multiply them together, we get positive 6. But once we add them together, we get negative 5. And the numbers are negative 3 and negative 2. Negative 2, negative 3. This is equal to 0. By setting each factor to be equal to 0, it implies either x equal to 2 or x equal to 3. Second solution. So far we have 4 solutions: 2, 3, 1, and 4. So altogether, we conclude that x equals 1, 2, 3, and 4. These are the solutions to this problem. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.